Hey guys, so previously we were talking about gas laws, and one of the laws which we were talking about is Boyle's law. So I solved about two questions previously, and I said in my next video I'm going to do two more examples, which is what we have here. We have 3 and 4 questions. Now, I said in my last video that if we are dealing with pressure, if the pressure if the unit is in millimeter mercury, that the volume will be what, in centimeter cube, right? And if the pressure is in what, in atm, the volume will be what, in liters. Now you have your pressure to be what, in millimeter mercury, and the standard pressure is what, 760 what, millimeter mercury, which is the same thing as what, 1 atm. So under STP, you have it to be what, 760 millimeter what, mercury, which is the same thing as what, 1 atm, right? So we're going to apply this to this question. So then your volume is in what, centimeter cube or diameter cube or what, liters. So now we are dealing with what, atm, which is the smallest unit, which smallest unit. So atm, so we are working with what, atm and what, and then liters. So Boyle's law, from the statement, we state that at a constant temperature, right? At a constant temperature, the pressure of a given mass of a gas is inversely proportional to what? To its volume. So this is Boyle's law, right? Which we have the formula to be P1 V1 equals to what? P2 V2, right? So now, solving this question, what pressure would be required to compress what, 7.75 liters of what, hydrogen at atmospheric pressure of what, 5 liters. Now what pressure, so the watt pressure becomes what, your P2, right? So P2, watt pressure would be required to compress 7.75 liters of what, of hydrogen. So the 7.75 liters becomes of what, your B1, which is the what, 7.7 liters, right? Then your V2 becomes what, 5 liters, right? So over here, your P1, you're not giving your P1, and I've told you that if your P1 is not being given, or if the pressure is not being given in the question, you should know that you're going to apply what we call STP, which is standard temperature and pressure. Now, if it was in Charles' law, would have made use of what, of temperature, which I'm going to do a video about Charles' law explaining the standard temperature. Now, over here we have your what, your standard what, pressure, which is what, 760 millimeter mercury, which is equal to what, 1 atm, right? So now you cannot use 760 millimeter mercury. Why? Because you have what, a lesser number. You have lesser number, 7.75, and then this is 5. So you cannot say 760 millimeter mercury. So you have to use what, 1 atm. So over here you have 1 atm. So we are looking for what, for P2. So we say P2 is equals to what, 1 atm times 7.75 liters all over what, 5 liters, right? So liters cancel what, liters. So we have our P2 to be equals to 1.55 what, liters. So what pressure? So sorry, we have our pressure to be what, atm. Sorry for that. So what pressure would be required? So it is 1.55 atmosphere that will be required to compress what, 7.75 liters of hydrogen at atmospheric pressure of what, 5 what, liters. So it is 1.55. So is that clear? So the next question now is what pressure. So let's go to question number 2. Question number 2 states that what pressure would be required to compress 350 watts centimeter cube of hydrogen at 750 watt millimeter mercury of what, 300 centimeter cube, temperature remaining what, constant. What pressure again? So that becomes our what, our P2. Remember our formula, P1 V1 equals to what, P2 V2, right? So we have, so what pressure? That because our what? Our P2. So we're looking for what? The second pressure, right? Then we have our what? Our V2. So our V2 over here becomes what? 300 centimeter cube, right? Then our P1, our P1 is equals to what? 700 millimeter what? Mercury, right? Then our V2, V1 rather is what? 350 what? Centimeter what? Cube. So very simple. Make this subject of formula. See, P2 is equals to P1 V1 all over what? V2. So we say P2 is equals to 700 millimeter mercury times 350 centimeter cube all over what? 300 centimeter cube, right? So centimeter cube cancels with what? Centimeter cube. So we have our P2 to be, so we say 700 times 350 times, all over 300. Okay, so after calculating, so over here I have